Hi guys, in this video we are going to discuss what are the three different techniques we use to represent your sine number. So in your last video we have been discussed about what is meant by floating point number and how this floating point number can be represented. So we have told we have two types, why it can be represent sine number and unsigned number. So unsigned number now will called as positive number, sine number now negative number. So this sine number can be represented in three different techniques and that will be discussed in this video. Your first technique will called a sine magnitude form, one's complement form and your two's complement form. So first we'll move to your first technique, which is called as sine magnitude form. So the sine magnitude form will called as a true representation format. Since here the bit pattern will be used, okay, the bit pattern will be used without any change along with your sine bit. Okay, here your bit pattern will be used without any change along with your sine bit. Suppose we have one bit for sine. Okay, suppose we have one bit for sine, we have one bit for your sine and your 7 bit is for you to represent your magnitude, For example, suppose if 1 bit is represent for sine and 2 bit for your magnitude. Okay, in the below example I have taken your 8 bit. Okay, in this 8 bit, 1 bit is going to represent your sine bit and the remaining bit, that is your remaining 7 bit, going to represent your magnitude. So which bit going to represent your sine bit? Okay, always your sine bit will be your leftmost bit, that is your MSB bit, always in the binary number will represent the sign of your number. Okay, so in your sine magnitude form, so your one bit going to show your sine bit. That sine bit will be always the leftmost bit, that is your MSB bit in the binary number will always represent your sign of your number. So I have a 8 bit from B0 to B7. So 1 going to represent your sine bit. The condition will be leftmost bit. So leftmost bit na MSB bit. So my MSB bit will be your B7 and this B7 going to represent your sine bit. The remaining bit, that is B0 to B7, going to represent your magnitude bit. So I told you it is a sine bit. Since it is a 1 bit, B7 will be a 1 bit. So it can be either 0 or 1. So if it is 0, this particular B7 going to represent a positive number. Suppose if B7 is 1 now, going to represent it is a negative number. Okay, so in your sine magnitude form, your leftmost bit, that is your MSB bit, going to tell you it is a sine bit. So either if it is 0, it is called as positive bit, if it is 1, a negative bit, and the remaining bit from B0 to B6 will called as magnitude bit. So we'll see one of your example for this sine magnitude form. Okay, so you have to represent this plus 24 in your sine magnitude form. Okay, plus 24 in your sine magnitude form. So this base going to represent it is a decimal number. So you have to find out what first you have to find out for 24 what will be your binary number. So if you have a calci, you can move to your base mode and give a data as 24 in your decimal and your output will you have to show it in your binary point, or you can do it your manual calculation. So first you have to calculate what will be your binary value for the given input. So I'll go with your manual calculation. So divide by 2. So 24 divided by 2. So it will be 12. Remainder will be 0. Again divide by 2. So 6. Remainder will be 0. Again divided by 2. 3. Remainder will be 0. Again divided by 2. Answer will be 1. And the remainder will be 1. And for this your binary value you have to write from the bottom to top. So bottom to top. So my value will be 0 0 0 1 1. So here I taken your 8 bit format. In the 8 bit format, 1 bit is going to tell you a sine bit and the remaining 7 bit, okay, remaining 7 bit going to represent your magnitude bit. Going to represent your magnitude bit. So that is from B0 to B6, B1, B2, B3, B4, B5, 6. So B0 to B7 going to show your magnitude bit. So you have to fill your remaining bit. You can fill it by remaining bit as 0. Okay. So you have been filled your magnitude bit. Now you have to fill your sign bit. Always your sign bit going to be a MSB bit. So my MSB bit will be a B7. So I told you if it is positive, you have to give it as 0. If it is negative, you have to give us 1. Since it is a positive number, so a B7 will be 0. Okay, so B7 going to represent your sign bit. Since the plus 24, so it is a positive number, now your B7 will be 0 and the remaining bit from B0 to B7 will called as magnitude bit. So this is the way you have to represent the given fixed point number, that is your signed number as in your sign magnitude form. The second example will be minus 14. Okay, first you have to calculate for the given number your binary value. So for 14, your binary value will be, if you need I'll show you a manual calculation. 14 divide by 2, 7, remainder will be 0. Again divide by 2, 3, remainder will be 1. Again divide by 2, 1, remainder 1. So your answer will be 111, 0. So 0, 111, 1. So up to B6 it should be a magnitude. So I am filling a remaining bit by 0. Okay, so B0 to B6 will called as magnitude bit. And now your last bit, that is your B7 going to represent your sign bit. So since the given number is negative, so if it is negative, you have to represent as 1. So B7 will called as sign bit and your remaining bit B0 to B7 will called as sign magnitude bit. So this is the way you have to represent in your sign magnitude form. Your second method will called as ones complement representation. So in this ones complement representation, the magnitude position we are going to show as in a ones complement form. So we have two part. One is sign part, other is sign bit, other is called as magnitude bit. For this magnitude bit, you have to take a ones complement form. After taking this magnitude form, then you have to include your sign bit. Okay. So for magnitude part, take a ones complement, then include your sign bit. So sign bit you have to follow what is being done in your sign magnitude form. So if sign bit, if it is positive value now, you will give it as 0. If it is negative value, you will give it as 1. So the same method we are going to follow here in ones complement. So what you have to do for magnitude part, you have to take ones complement, then include your sign bit. So if it is positive number, include 0. If it is negative number, include 1. So I'll give one example. Represent this minus 14 in ones complement form. So first we have to calculate what will be the 14 binary value. So already we have calculated 14 binary value will be 1110. So for this 1110, what this will be a magnitude part. This 1110 will called as magnitude part. For this magnitude part, you have to take what? Ones complement. So you know how to take ones complement. 1 will be replaced as 0 and 0 will be replaced to 1. So the ones complement for 14 will be 0001. Okay, so 0001. So you have been taken your magnitude ones complement 0001. Now you have to include my sign bit. So my sign bit, since it is the negative value, okay, so you have to include your sign bit as 1. So the answer will be so magnitude part 0001. So this is your magnitude. So now after taking ones complement for magnitude, then you have to include a sign bit. Since my sign is minus 14, so it is a negative value, sign bit will be 1. So the the MSB bit, that is the leftmost bit, going to represent your sign bit, and the remaining bit will called as magnitude bit. For that magnitude bit we have taken 1's complement of your 14. So next we'll move to your 2's complement representation. The same thing what we done in your 1's complement, no, the same thing method will be followed. Only one changes. For the magnitude part we have to take 2's complement. Okay, for magnitude part we have to take a 2's complement. Okay, where in your previous method we have taken a 1's complement, now here you have to take a 2's complement. So 2's complement, now first you have to take 1's complement for the given number, add 1 to that, then you will get a 2's complement value. So for magnitude part you have to take 2's complement and then you have to add your sign bit. So in case of it is negative value, your sign bit will be 1 and put the magnitude part as a 2's complement of your given number. For same example, minus 14 we are going to represent in the 2's complement form. So we know 14 binary value will be 1110. You have to take a 2's complement. So first take a 1's complement. 1's complement of 14 will be 0001. Add 1 to that. So 1 plus 1 0. A carry will be 1. So the 2's complement will be 0010. Okay. So now here I have to represent this in a format. So 0010 we have taken for magnitude what, 2's complement. So this is the magnitude part will called as 2's complement of your 14. Then you have to add your sign bit. So my sign bit will be, it is a negative value, so my sign bit will be 1. So always remember your sign bit should be represented in your leftmost bit. That is your MSB bit will always indicate your sign bit. So you have to add only to your left hand side, not to your right hand side. So this one going to represent a sign bit and the remaining magnitude will called as 2's complement of 14. So this is the way you have to represent your sign number in your fixed point representation. Thank you.